let's go to the two important theorem in rotational mechanics, that is parallel axis theorem and perpendicular axis theorem. Perpendicular axis theorem says that is if there is any lamina, that is we are saying the word two-dimensional body. What we have in our course is perpendicular axis theorem for lamina, that is two-dimensional bodies, not for the three-dimensional bodies. Otherwise we have perpendicular axis theorem for three-dimensional bodies also, but that is not in our course. So let's understand what is perpendicular axis theorem for two-dimensional bodies like a lamina. It says if you know the moment of inertia about any one axis, let's say I call this as x dash axis, and any other axis, that is y dash axis. Suppose the moment of inertia of this lamina is known about two axes, I x dash and I y dash is known, and both these axes, they lie, this body lie in that plane, that is xy plane it lies. So moment of inertia of this body about this axis, that is I z dash, is going to be I x dash plus I y dash. So this is perpendicular theorem. Over here the important thing to understand is that is the body is lying in this x and y plane. Had it been lying in y and z plane, then this I x dash is going to be I y dash plus I z dash. Please understand that. So over here it is lying in xy plane, so moment of inertia about I x and I y, that makes moment of inertia about z axis, and it is important that is z axis, it has to pass through the intersection of these two axes. It is not z axis is over here. These two axes, they are perpendicular to each other. We know the moment of inertia of this body about this axis, we know the moment of inertia of this body about this axis, then the moment of inertia of this body about an axis which is perpendicular to this, plane, and passing through the intersection of these two, that is z dash axis, is going to be I x dash plus I y dash. So this is perpendicular axis theorem for lamina. Over here one thing to understand is that there is no word, we have not used any word like center of mass, and this is applicable only for the two-dimensional bodies. Now how we are going to apply perpendicular theorem? Over here, let's say this is a disk. This is a disk of mass m, radius r. We have found mass m, radius r. This is the radius r. We have found that is moment of inertia of this disk about this axis is mr square by 2. About this axis mr square by 2. But someone says what is the moment of inertia about along this diameter? That is I y dash. What is that? We can say that is obviously this is a lamina, the thickness is almost equal to 0. So whatsoever is the moment of inertia about this axis, let's say I, about this axis will also be I. Obviously that is symmetrical distribution, the same distribution. These two axes we can take it as perpendicular to each other. So if this represents I x dash, this represents y dash. So I x dash is I plus I y dash is I is equal to moment of inertia about z axis. What is moment of inertia about z axis? That is mr square by 2. We have done it. So this is 2I is equal to mr square by 2. So I comes out to be mr square by 4. That is moment of inertia of this body about any diameter for this disk is going to be mr square by 4. So this way you can use perpendicular axis theorem.